pi code activity. This is a part of the series of activities that I would use on my Pi Week with my Pi Olympics competitions. One day, one of my students, as 7th graders often do, asked me, why do we have to learn pi, the digits of pi? I never required them to memorize anything more than 3.14 because that's the general rounding of it. But when a kid asks a question, I always try to answer it. So I looked it up. I'm like, what are the digits of pi used for? And one of the things that came up was cryptography. They've been using the digits of pi to write codes for a really long time. And what I found in teaching this is that it teaches students how to work towards a goal when they literally have very little place to start. But its purpose is to really push kids out of their comfort zone. The competition would start like this. I would simply give them a list of numbers, and I'd say, this is an encoded message. And then we'd talk about something called alpha-numeric codes, and talk about things like, well, could you make a straight alphanumeric code with a single digit representing each letter? And most students go, and they have to think for a minute. Some of them catch on right away, and they're like, well, no, there are 26 numbers, or 26 letters, and there's only 10 digits. So you couldn't do a single digit to represent each letter of the alphabet. Then I pose the question, well, then what else could you do? And see if they can wrestle with that for a little bit. Then I talk about, what about two-digit combinations? How many two-digit numbers are there out there? Are there enough to represent all of the letters of the alphabet? And pretty soon they figure out, yeah, there are. Especially if you represent the single digits as 0, 1, 0, 2, and so on and so forth, then they become a two-digit number. Then you have plenty, because you have at least 99. And if not, then you have 90, and that's way more than 26. And then I tell them, well, what an alphanumeric code does is it pairs certain digits with letters. And so if this combination of digits, that represents this letter. I wrote a message using that type of coding. And that's all I gave them. Then they had to do the rest themselves. I would tell them, if anybody can figure it out with just what I've given you, you get 1,000 points for your Pi Olympics team. I never had any students that were able to crack the code without at least 2 clues. So while they would wrestle with it and get close, I would then the next day give them clue number 1, which is that the code, I made my alphabet using 3-digit clusters. And many of them would then break up their code like this into 3-digit chunks. And once they did that, you can see that there are several chunks that repeat. And I would tell them, I'm like, yeah. I wouldn't tell the whole class because I would just say, And then among their teams, I would hear them talk about that. Ooh, look at that, 612 repeats 4 times. 914, that repeats a lot. And so I was like, yep, it does. Do letters repeat? Oh, they do. And that's all I would say. And let them wrestle with it for a while. On the 3rd day, I would give them clue number 2. And the clue number 2 was that the key is on the piece of pie. And that sounds like a riddle, but it's kind of a riddle, but not really. Because on the first day of the Olympics, I gave them a printed sheet of paper that had the digits of pi that I printed off from one of the websites that has like 1,000,000 digits of pi, or one of them is 10,000 digits of pi. And all you need is the first page. And the first page usually has 3,000 or 4,000 digits of pi, depending on how small of a type it is. But I would have given them that on the first day of the Pi Olympics, and sometimes before that, because one of the competitions is to see who can memorize the most digits of pi, and that's what they would use to learn the digits of pi. So clue 2 is that the key to cracking the code is on your piece of pie. And they're like, what, this that you gave us? Yes. The code that I made my alphabet with is on that paper somewhere. And they're like, but there's a lot of digits here. And I'm like, yes, there are. But again, a code is not supposed to be easy to crack. Otherwise, why write it in code? Now, I had some kids that got close to it with the second clue, but I never had anybody crack it from the second clue. So clue number 3 is that the code key starts on line 4. Now that depends on how you have your pie piece printed out. And I would actually use the piece of pie that they had printed out. So it was the exact same piece that they were using. That way line 4 all started the same way. But I would use line 4, and that's what I would say. My alphabet starts. No, I would say the code key starts on line 4. I didn't say anything about the alphabet yet. Now, some students were able to crack the code from there because they would break line 4 up into 3-digit chunks. Several students, so most students, were not able to connect the first clue with the third clue. And that's part of this, is not telling them all how to do it. They're so used to video games and things telling them what the next step is, using a cheat code and getting a hint to figure it out rather than learning how to think on their own and to figure these things out and to put these things together. I did have a couple of kids that figured it out after clue number 3. And each time I gave a clue, the point value was less. So if you could figure it out without a clue, 5,000 points. Clue number 1, it dropped to 500 points. Clue number 2, 400. Clue number 3, it dropped down to 200 points. And that's because it's not that hard to solve after clue number 3. If I still didn't have anybody that had solved it by clue number 3, then I gave clue number 4. And clue number 4 tells you what the letter A is. The first 3-digit chunk there, that's A. So anytime you see 038, that's A. Now, I never had to go any further than this. Somebody would crack the code with clue number 4. I would oftentimes, especially with my classes of students who struggle in math, most of the time they couldn't get it after this because they had put up a wall. I don't know math, so therefore I can't figure this out. And that's actually true for a lot of adults as well. They're like, I can't figure this out. I don't know what to do. And because you have that line of thinking, your brain just doesn't even put in the effort to think about it. Your brain wants to just conserve energy, and if I can't figure it out, why think? So you have to open your mind to the possibility that this is a 7th grade class, and it's a 7th grade problem, not a college level encryption problem. This is a 7th grade problem, and it's not that difficult. So most people could get the alphabet after that, and once they get the alphabet, then they're usually able to crack the code and get the message. So the message, if you cracked the code, is pi is so irrational. But this is how I wrote the code. So to teach the kids how to solve it is one thing. To actually write an encoded message yourself, this is what I did. I started with a message and an alphabet. And I made the alphabet the way I described. I picked a line on their piece of pie page, and I wrote 3-digit chunks, and I wrote an alphabet above those 3-digit chunks on my copy of the paper. Then I sort of separated out the letters so I could have some space to write it. And I would say, okay, so on my alphabet, what's P? Well, P is 527. So I'd write 527 over P. And then I is 612. So above each I would write 612. And S is 914. So above each S, I wrote 914. And I continued in this way until I had every letter from the code above the letter that is represented in the message. And then you get the final encoded message. So those digits are the ones that I used to write the message. So I took those 3-digit clusters and just typed them as if they were not 3-digit clusters in a straight line of numbers. And as you can see, you can't tell what it says. You can see some repeats and some patterns in there. If you look really closely, you can see the 038 on the second line, and you already know that that's A from the last slide. There's another 038 almost at the end there, like 6 digits from the end, it starts again. So you can see that there are patterns you can do. Once you get the 3-digit cluster thing, it's just a matter of finding your alphabet. Some things to consider. Make sure that you release the clues at a time when all kids have access. So I would use a bulletin board outside my classroom, and I would also put it on in my online class announcement page at 8 a.m. every day. So as soon as the kids were released into the hallway, they could come by my bulletin board and read the next clue. And then they could work on it throughout the day. Or if they weren't able to come by my room, they could check on their computer on my class announcements page and they would see the clue there. But they would have to be the ones that went and got the clue. During their class time, I would have the clue on the front of the room, in the front of the room, so they could see it and work with their teams. I didn't allow much time in class for them to work on the code because we were doing so many other activities in class. I'd be like, okay, here's your code. That's all the time you get. The rest of it's on you. And a lot of students don't like being able or being forced to do something on their own and not having their hand held through it. So they will resist on that. And I just keep encouraging them. I'm like, guys, you can do this. I promise you can do this. It's not that hard. It's not obvious, though. I always tell them I didn't make it obvious because that's an insult to your intelligence. But each clue, if you think about it and make some notes on your paper and try different things, see if it works. You might have an idea of what you think it might be, and then you'd see if it works. Some kids would just out and out guess some weird saying to see if that's what my message was. And I would let them try, but I made it different every year. And it was always something super cheesy and very mathy. So nobody ever just randomly guessed my message. And I started by handing them the message, and I would tell them a story. And this story would be something along the lines of, you guys intercepted a message from headquarters to the battlefield, and you are the one that has to try and decode it so you know what's happening, what message your opponents are sending. And telling them you need to decrypt it. Then I would describe what a basic alpha-numeric code is, kind of like on the Christmas story, his little orphan Annie decoder pen. It was an alpha-numeric code. You turn it to a certain letter, and each letter had a number that represented it. And then she would read out the numbers on the radio, and he would decode it. And it was a crummy commercial. Most kids feel very inadequate when they're given the code to begin with. And I just keep encouraging them that the purpose of a code is to be unbreakable unless you have the key. So then they're like, well, then why should I even try? I'm like, well, because it is possible to break it. It's been done before. There are whole branches of computer science that are based around breaking codes, Morse code and other sorts of codes that are encoded and encrypted in different ways. So I would have them tell them that this is like a whole science, a whole branch of mathematics, which is kind of a science also, but I've also heard it described as an art. I don't see much creativity in it, but I suppose you could get creative with it. But the whole thing is that each people at the ends of the message have the key. But if you intercept the message itself, it doesn't come with the key. The key is in the hands of the people who are to read the message or who were sending the message. And I didn't make the codes very long. I would often, once we had it all figured out and decoded, I would give them a bonus code. And it would be an encoded message. And I would say it's the same type of key, but I started the alphabet at a different location. And would see if anybody could get it from there. And this one was optional, so they didn't have to do it. They could do it to get some extra points for their team. Because they already knew how the system worked, though, I didn't make it worth 1,000 points. I made it worth, I think it was 200 points. All they had to do was find the beginning of the alphabet, the A, and they could get it by breaking it into clusters and finding those repeated clusters on the board. So anyway, that's one of the things that I would do during my Pi Olympics. Some Pi coding. It's fun. Give it a try. I also gave them an extra credit thing to write me an encoded message using the Pi as a code. So they would use either my alphabet that I already used, or they would design their own alphabet, and then they would tell me where A is, and I would figure out their message. Thanks for watching. Have fun in class.